Hello, 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 hello. I have no idea if volume is coming, so give me like 2 minutes to set up the volume. Am I audible? Am I audible? Hello, 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 hello. Yeah, I am audible. I'll start in 2 minutes. I'll start in 2 minutes. Give me 1 minute. I think I'm even once bit earlier. I have an exam, so I can't really spend so much. Since people were asking about doing recursion, that's I'll just do a short thing on recursion. Why is my mobile acting up? I actually can't open Twitter on the PC because I'm streaming. My Twitter is not working for some reason. Live now, teaching recursion. I'll start in 1 minute. Hello, hello, hi. Yeah, so basically what I have set up is here there is Excalibur where I'll teach, and here's one C compile. I'll code in C if it's not a problem. I can code in any language if you want, but I'll code in C. That would be better, I guess. I'll code in C and show you examples. Hi, hi, hello, hello. So I'll start. Give me one second. So before even starting recursion, you should know what recursion is. Okay. So let's say there's A here, B, and C. Okay. So recursion can be of two types. Okay. Recursion is kind of a thing. Wait, let me write it out first. Okay. So let's say recursion is a kind of a thing that means that a function will call itself repeatedly. That's the main logic. So let's say if there is a function f, right? So function f will keep on calling itself. That's recursion. Basically, let's say what we are basically doing, let's say if we are writing a function, right? Def func n, for example, and the thing we are trying to do is that we'll call the function in itself in some way or the other. Okay, this is just pseudocode. Don't think I'm writing Python or anything. So if we are defining a function, the function will call itself inside the function. That's one way. Another way might be a function is calling another function. That function will call another function, and lastly C will call it. Something like this. So it's forming a cycle, right? Like A calls B, B calls C, and C calls A. So this is also recursion in a way. So let's say if there's a function here, right? Let's say this is def A, and let's say I'm calling B in it. And let's say if we have def B and we are calling C in it. And let's say we have def C and we are calling A in it. So this kind of thing is also a recursion. Recursion is of two types where something calls itself, F calls F, or F, let's say A calls B, calls C, calls A. Okay. So I hope you understand what actually recursion is. This is what recursion is in itself. Then what is my rule? Okay. So you have to understand something. The first rule you have understood. I'll just write it here. The rules. The first rule is simple, that the function will call itself in any one of the way above. Second way. Now I will explain you why we need the second thing. Let's say there is a function f n, let's say, and we are calling f n minus 1. Do you see what's the problem? Let's say this function f n value is 3 first. Okay. So when it is 3, it will call f of 2. When it is f of 2, it will call f of 1, f of 1, and it will go on. No, it is never ending. No. So this becomes an infinite loop and you immediately get segmentation fault. Okay. So like for example, if I write this, no, let's say int, give me one example, no, fn, and I'll just call return f of n minus 1. Okay. And I'll call, let's say, f of 3, int a equal to f of 3. Okay. I'll run this segmentation fault. Okay. That means it will go on infinitely. So what do we need here? We need an exit condition. Exit condition. An exit condition, as in like when do we need to stop? So let's say if we you wanted to stop, let's say if n is less than 0, return 0. As in we are ending. We are not calling the function anymore. So let's try to run this. Code execution successful. No segmentation. I didn't return anything, like print anything, so you're not seeing anything. But you can see that if I put an exit condition, this is my exit condition, and this is my main recursion. You have seen. So one condition will be my the function will call itself, and there will be an exit condition. You have to realize these two. So there are many kind of examples of how we can apply factorial, matlab recursion. So first we'll try to do factorial. Okay. How do we do? Let me write the code first. I think that would be better, right? Yeah, it's very silent, I know, but give me 1 second. Um, n into f of n. I'm writing this code like from blank, so give me some time. So I'll just do printf. The reason I'm doing C is because, yeah, I have been coding in C for the last 1 week, so just it's in my like I can under. Well, let's run this. 5 should be 120. No, yeah, it's 120. How am I running this? Okay. How does this factorial actually run? Okay. So let's just take a screenshot of this first so that I can explain it to you in Excali. Why can't I take a screenshot? Yeah, I'll take the screenshot and explain it to anyway Excali. Okay. Let me check chat if people are understanding or something. If people have doubt. Yeah, if I'll explain you how recursion works in detail using this example. Okay. So we will just use, let's say, f of 5. Yeah, no, this is not from Striver's videos. I have watched his videos, but yeah, this is from the NPTEL lectures in IIT. IITs have some NPTEL lectures, no? So this is my notes when I studied this. So whatever I'm teaching you right now. So yeah, so let's say f of 5. So when you run f of 5, is n is let's say is n equal to 1? No. So we have to return n into f of n, right? So we'll go down one step. So now what is my now we are running f of n minus 1, that is f of 4. Now f of 4 is not 1, so we'll not return 1. So now we'll go down one step more. That's f of 3. Yeah. I hope it helps you in your Viva tomorrow. Then it will go to f of 2. And let's say, I'll just put this arrow here. That would be better because otherwise can't see the next one. Okay. So let's say f of 2. And now we'll finally, let's say when f of 2 is there, when finally f of 1 comes. Okay. Okay. Let's say f of 1 comes, then n is equal to 1. So I have to return 1. Now we move backwards from this. Like this. We move backwards. Bro, that is very thick line, bro. Yeah, backwards. So what will we come here to come this to be? it will become n into f of 1. So it will become 2 into f of 1. We went one step backward. Okay. Now what is f of 1? We have to return 1. So this becomes 2 into 1 is equal to 2. Okay. We went back 2. Now this is my value of f of 2. Okay. Now we'll go back one more step. Because that got satisfied. Now when we go one back step, it will be what? N into f of n. So that will be 3 into f of 2. Now what is f of 2? We just found out. 3 into 2 as in 6. Then again we'll go back. You understand the logic, no? Like then it will become what? 4 into f of 3. That is, sorry, 4 into f of 3. 4 into f of 3. Recurrence revise करा देंगे. I'll explain recurrence relations when Tower of Hanoi after this. Otherwise, you can't do recurrence relation sums also, no? Like some things are very simple and people tend to overcomplicate that. So something like this, I am not like going above anymore. Might be did I do a calculation mistake? Might be there is a calculation mistake. Yeah, don't judge my calculation mistakes. But yeah, so this is the thing. Now, basically, this is how this actually works. But what I think it works like, and it actually works like this, is it works like a stack. Okay, how does it work like a stack? So first, when we are calling a function, it goes to the bottom of the stack. So this is f of 5. Then we go to the f of 4. Then we do the f of 3, and then this is the f of 1. Sorry, 2. Yeah, if there is silly mistakes or calculation errors, please fix them yourself. Yeah, because yeah, I am doing this like fresh, so I have zero idea. So if you can see, this is how the stack is done. We filled the stack like this. Now we are popping one by one. This gets popped out, this gets popped out, this gets popped out, this gets popped out, and this gets popped. The final result is our answer. That is how basically recursion works. Okay, how does it make sense that the factorial value before it? Okay, so yeah, let me. Okay, if you are saying factorial, I'll explain this once more. I think you didn't understand this one. See, when we are at f of 5, right? Let's say f of 5. Inside that f of 5, there is a f of 3, 4. F of, it's like you are filling this stack and then emptying it. If you don't understand it with stack, let me explain it with some other example. Like recursion logic is same everywhere, right? So here what happens is that you have to understand is that let's say this is f of 5, right? When f of 5 is there, it calls f of 4 in it, and f of 4 calls f of 3 in it, then f of 3 calls f of 2 in it, and f of 1, 2 calls f of 1 in it. Now if you see logic, now I say how the value is getting stored when we are going back. No, you have to realize what am I returning in f of 2. In f of 2, what am I returning? We are doing returning n dot f of n minus 1, which is what? 2 into 1. So what am I doing? This 2 gets stored here. The code is running like this, no? The code is running like this, no? Like it will move in this order. So when you are moving in this order, right? So let's say this, um, wait. Yeah. So basically, we are calculating return n first. So we know the code knows 2. Then we are going to a new function f of 1. And then that is getting calculated, and when it is calculated, this value comes back here. It's just a value, no, like 2 into 5. So what, like if I write, let's say if I write this 2 into 5 plus 6, 5 minus 6. So how does it get stored? 2 into first 5 minus 6 is calculated, that is minus 1. Then we are doing that. If you understand what I mean, no, it's like a, we are calling a second function, but in that thing, in here, the second function is not a second function. It's the function itself in this case. The function calls is stored in stack memory of the processor. Yeah, that's the thing. In reality, it is stored in a stack, which I explained. No, this whole mechanism. I don't think you'll need to know how the stack works currently, but I'll tell you one process later on. So that's it for Fibonacci. Okay, I'll do one example of each type. No, factorial. No, I'll do Fibonacci. Okay. Let me write Fibonacci. See, I have not written them in ages, so like give me time. If you noticed in the earlier one, we didn't have two things, only one thing if we had. I think fifth element is 5, no? Sixth element is what? 8? Yeah, it's correct. How does Fibonacci work? Okay. Let us teach you. There are two types of recursion, how recursions look like or anything. One is the stack thing which I told. Another way is storing it in like a tree or something. How does this tree form thing work? Let's do the tree form thing. So let's say this is my, let's say, function of 5. Okay, this function of 5 will be broken down into two things. Nothing but function of n minus 1, that is a function of 4, and function of 3, right? And function of 4 will be broken down into what? Function of 3, function of 2, and this will be broken down into function of 2 and function of 1, right? And function of 3 will be broken down in what? Function of 2 and function of 1. So this looks like a tree, right? This looks exactly like a tree. So this is the same thing what we are doing, but this is very linear structure. No, here it's not linear. Here it's depending on two values here. If you notice, it is depending on two values here. That's why we have kind of have a tree structure. I'll draw the tree. This tree looks like this. So if n is less than 2, then return n. So see, we'll stop at 1 and 2. Actually, we should stop at 2. We should stop at 1 and 0. But I'm ending till 2. You can guess the next one, right? The 2 will break down also. So like the earlier one, what we, after storing it, we were going up. Here also, after storing it will go up. That's why it is getting stored like this. Finally f5 value will come. So that is the main logic behind how recursion works, even in this or in any other form. So there are many other codes which you can try. This kind of execution is called as tracing execution. Okay. Now recursion, why are we using recursion? Okay. Remember something. Recursion, as I explained, is a stack, right? It's kind of a stack call. So we can implement this using a stack also. We can implement this using a stack also. We can also do it by a while loop. You know, like in your, I think in your schools, everybody has done this. Nobody used to recursion for factorial. What did people used to do? What did function of n for factorial? Factorial, it would used to be, let's say, while n minus minus answer is equal to answer into n, and answer is equal to 1, return answer. Something was like this. Nah, I have no idea. I think this was the iterative code for that. It's not running. Why it's not running? N greater than 1. I don't know. Why isn't it not running? Yeah, and I didn't do n minus minus. Sorry. Bro, did it get stuck? I'll just reset. Right. I think it will run this time. Yeah, 720. It's correct. So you saw we put it like in a iterative form. You can do it in recursive or iterative. It's totally up to you. There are many different types of recursion sums which I'll not, like, I don't have that much time to explain every sum by detail. So what you should do is that go to lead code, and I think lead code has a tag of recursion, right? Do the easy. Whatever I explained to you should be able to do the easy. So like recursion basically is something as dimag hata do. Don't think as simple as that. First, in a recursive thing, you have to first, how do I think? Okay, how do I think? First is exit condition. I think when should I stop? Okay. Next, what is the recursion? What is the recursion? What am I trying to do? What am I trying to achieve? That's the thought process of my recursion. So let's try to do one question. I'll explain this to you using my thought process. Okay, so let's say if I input a number, okay, let's say if I input a number 1, 2, 3, 4, 5, 6, my code should be able to print it in a reverse manner. Okay, that's the logic. Okay, no, I don't think this is a good example to teach anyone. So I'll do the binaries. I think binary search would be better, na? Tell me in chat. Should I do this simple example first, or like should I do binary chat? Binary search. Binary search would be better, no, because binary search is a very important thing anyways. So binary search, well, let's do a binary search. Int array 6 is equal to 4 to, oh, binary search, the list has to be sorted. So I can't use any random stuff. Okay, so let this be my array, right? So let's try to find printf. I'm just writing the boilerplate code, bs array and n. And let's try to find 75, okay? And we'll do the array and array in in target, okay? How do we try to achieve this? Okay, so first we have to set a, let's say we'll do a int low and high. Okay, how do we achieve the binary search? Okay, let's try to solve this binary search question. Okay, how do I try to do this? Okay, let's say this is my array, right? Not this, not this. Where is box? Where is box? Yeah. Let's say this is my array, right? Binary search matlab what? It is already sorted, no? It's already sorted. So let me just copy paste this. I think that would be better, no? What the fuck did happen here? Why isn't that copy pasting? Yeah. Okay. I think this is the thing. This is already sorted. We have to find 75. 75 is a very easy example. Let's not find 75. We'll have 15. We have to find 15. So what we'll do is that we will see the middle value first. Okay. अगर middle value में हुआ, then it's good. Otherwise, we'll see the left half, because it's, if it's sorted, agar that is smaller than 75, it will be on the left side, no? And it is on the right side, then it will be on the right side. That's the basic logic, na? So let's try to find the middle ground first. Int mid is equal to low plus high by 2, right? This is the middle ground. Okay, now if, let's say we see array mid is equal to my target, means we found it. Let's say return 1, as in we found the thing. Or we can just find the, sorry, not, yeah, we can just return array mid or the value, right? Now we can find, say which element it is at. Oh, so let's say return mid. Now else if it is not. Now what did I say? If array mid will be less than the target value. That means what? Array mid is less than the target value. Means target value should be here. So we will just do bs return bs a low array and target will be always target. Why did I do this? I'll explain it in a second. Now if let's say it will be less, no, this will be greater, then this will be I think low and mid plus 1. Okay, why did I do this? Let me explain this, let me explain this, let me explain this. Okay, if array mid is less than t, that means it is in this region, it is in this region, then we have to just search what? If this is mid, we have to search mid plus 1 till my highest value, this is this one, right? Okay, and if it is less, the t is less than array dot mid, if the target should be on this side, we'll search from what? The low to mid minus 1. It should be inside this. Now, why are we doing recursion? Because we don't give a fuck basically how it works later on. Now my sub array is this. It will find its own middle and keep on searching. And if it is not found, that means what? If it is not found, that means it is not there. As simple as that. But if we didn't put any, if we didn't put an exit condition, no. The exit condition is what? When both are same, like as in like we are doing half, right? Till we get the same value. So if low is less than high, then we'll return 0. Let's see if this runs. I don't know if it will run or not. It's an error. Yeah, I didn't call the error. Sorry. Low will be 0 and high will be 5. High undeclared. High undeclared. Oh, I wrote it left. Hello. Yeah, these stuff are a part of life. You have to accept errors. BS. Okay, I never named it BS. Okay, it's calling 0. Wait, let me see what's the error now. Int array, high low, int k, int meet. Yeah, wait. Why is it not working? Okay, leave it. I'll explain it. You understood how the logic works. That's what matters. I don't know why is it not working right now. That's the basic logic if you understand. Okay. Let me read the chat. Wait. Yes, you can. Just do. I'll tell you how to practice on leak code. Okay. I'll explain it. I think this is the thing for binary search. I don't know why the code is not working. It's showing 0 for some reason. I don't know why. Oh. I think it's because of this. Uh, I don't know. Why is low greater than equal to high? Return 0. Mm, 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 mm. Fuck it. This is basically how it works. This is the main logic of the code. This part. Okay. The exit condition, everything is correct. I don't know why the fuck it is not working. But yeah. Always remember that. Okay. There is one common mistake that people do is that two things. I told you the base case people try to forget. Let's say the base case is never reached only, right? Let's say you make a function which increments values, okay? And you kept a, let's say n is first at n is equal to 1, and you're incrementing the value, and you kept a base case where when n equal to 0. That's baseless, right? It's useless. Okay. And never try to mix for loops, like never try to mix, like this is a big no-no, is don't mix loops with recursion. It's a disaster, like recipe for disaster. Don't like try to avoid putting loops with recursion. Okay, and now I will show you how stuff works in like. Have you guys ever played Tower of Hanoi? I don't know if you have heard of it. Tower of Hanoi is basically like this. There is three pegs like this. There are three pegs. I don't know if you guys have ever seen or played it. Have you ever even faced this sum or not? So in Tower of Hanoi, basically what works is that basically there are series of pegs like this. The upper one is always smaller than the lower one. Okay, that is the thing. You have to remember this. Okay, and your aim is to move it from this peg to this peg. That is my aim. Okay, that is my aim. And how can we do it? Just use recursion. Don't think much. Use recursion. Dimag lagao. Don't think much. So logically, what can we do? You have to move it to C. Let's try to move. Let's say this A has n pegs. Okay. Now we move n minus 1 pegs to B. How do we move it? I don't give a fuck. Simply don't think about how it works. So let's say if it takes, if let's say let's define like this, Cn is basically the number of moves to move n pegs. So if we move n pegs to B, it will take Cn minus 1 moves. Now we move that one peg from A to C. Okay. So that is what one move. And now we move n minus 1 pegs from B to C. So that's C n minus 1 moves. Right. So total moves kitna? C n minus 1 plus 1. Somebody told how to do recurrence relations, right? I think somebody asked how to do recurrence relations. This is the recurrence relation for Tower of Hanoi. Okay. This is how you derive that. So this is the logic of recursion, and we derive the equation for the number of stuff. So basically, like, if you have this logic, right, you can easily find out the number of moves taken in the Tower of Hanoi. This might be a question, you can do it. Find total number, using this logically, total number of different binary trees, binary search trees possible with n different nodes. This is a very good question. This is a lead code hard actually. I think this is a lead code hard, which people will take ages to do. But it's a one line answer if you can return the correct answer, if you know the recurrence relation. So try to solve it using recurrence relation and see if you can get it. Okay, that's it. And I think what's left. And I think wait, I'll do this. So somebody asked me is how the recursion looks like, right? Somebody asked me how this recursion looks like, and I have a picture, I guess, from the place I studied myself. Is it exactly looks like? Wait, if I don't, I have this image. Do I have this image? Let me see. I'll actually show this image. Yeah, I got the image. This is how actually recursion works. If you notice, first you're calling 3, then 3 gets stacked up on 2, and 1 gets stacked up on 1, and 0 gets stacked up there. Slowly, then we start moving the stack down, and it keeps on multiplying. If you remember, this one was this thing. This is what I was trying to explain. I might have not explained it perfectly. This is what actually goes on in the computer and as a stack. Okay. Now I think I'll end it here only. I will share the recursion list, problem list. I'll send it. I'll send it in the chat. Posted it like 3 4 times. You can see. I don't know how many viewers I have right now. Yeah, 3 4 are there. Yeah, wait. I'll check if what's wrong. I didn't see the error, so I'll just check it. Oh yeah, yeah. Sorry, sorry. I think it should run now. I don't know what's going wrong here, but low, high. Let's try to decode this, and then I'll then try to do it. Let me try to decode this. Let me think how you can do it. Yeah, just bear with me for 2 minutes, 3 minutes. Hmm. How can I approach it with recursion? Because see, I have that one memorized, like the normal one. I don't use the recursion in this one. I use the. So wait. Let me try to do this. I'll do a -1 so that I understand I'm not fucking up. This will be a high load greater than. Yeah. It's working. It was my mistake. So basically, this has to be higher than. I was doing high, low less than high for some stupid reason. It will be low greater than high. This is the binary search code. I was doing a very silly mistake. Sorry. High. So this is how the whole recursion works. I think I'll end it here. I don't think there is any other topic that is left in recursion. Is there any topic? I have no idea. There's a there's some sums I think share, which I did it from the course I was telling. So these are the sums. I'll just write the sums. You can try it on your own on your free time. These are the sums. So first, write a recursive to search an element in array. We just did it with binary search. Recursive to count the digits of a positive integer. If you can count the digits, you can also sum it. And reverse a null terminated string. Reverse a decimal to binary. String palindrome or not. To copy one array to another. These are the 6 things you can try out. I'm just giving them for fun. And this is the basic concept of recursion. Like, however, you should think about recursion is that how can we lessen my time? I am bothered. We will break the whole problem into 2 3 parts. Okay. And as many parts. I'm just saying 2 3 4 5, as many parts you want. And when you're working with the 2 3 parts, right, you should try to not think what's going on inside. So what we are trying to do is that when we have n stuff, no, we Try to think how can we delegate n minus 1 stuff to do it, or n minus 2 stuff to do it, or n by 2 stuff to do it. And okay, then we'll call the function for n by 2, and it will keep on calling till the base case. So you have to divide the problem into few parts. That's the logic. If you want to, when you will do trees or anything, right? The trees, everything is recursion. Like if you understand how recursion works, every tree code will be like less than 5 6 lines. So that's the thing. Yeah, I'll just close the stream now. Thank you for joining, guys. Chalo, bye. Good night. I'll go and study now. How do I close the thing? Okay, chalo. Good night.